60 years after Giant Mine first released arsenic trioxide into our landscape, the Yellowknife region still carries its legacy. Today, Aurora Research Institute and partners are examining how that contamination moves with spring meltwaters and how our communities can help understand recovery.
I'm Heather Jameson. I'm a professor of environmental geochemistry at Queen's University, and I'm standing just a few kilometers north of Yellowknife in an area that's been impacted by former gold mining and processing. About 12 years ago, Mike Palmer, who's from Yellowknife, called me up and asked if we could collaborate, and he had some great ideas, and we've been working together ever since.
We record the temperature in the ground and the moisture in the ground so we get a sense of how much of the ground is thawing and when, and how much moisture is there. So we have these loggers installed, and we can download them via Bluetooth, and then I can save it.
We're standing on some rocks just a little bit north of Yellowknife. We're right beside the Ingram Trail, the highway, and just over there is the former Giant Mine gold mine that operated for 50 years, closed in 1999, and we're looking at the impact of the arsenic that came out of the roaster onto this landscape here.
So this is probably an old notification. I'm not sure what year it's from, but it says, "Notice, water contains arsenic unfit for drinking or cooking by order of the Public Health Office." So it gives an indication that people did come out here and actually use the area around Giant. And there was some concern in the early days about people getting sick from drinking that water.
Back in the 1950s, when the gas came from the stacks over in this direction and the particles settled, they were washed down by rain and snow melt and collected in these little soil pockets.
The 2012 rerouting of the Ingram Trail opened forgotten stretches of land. This area was used extensively in the past by local indigenous peoples for hunting, trapping, and picking of berries and medicinal plants. At Pocket Lake, our crew goes out to assess several critical data points. Our trainees ask questions like, where did the arsenic go since it was deposited on the landscape more than 70 years ago? And more specific questions like, how much arsenic moves downwards in the soil? And how much is washed off the landscape and into the water? Our results show that each spring, the pulse of melting snow washes arsenic from the land to surrounding bodies of water. Measuring this process in the short period of time is vital to our understanding of the processes controlling recovery.
This is what we call a weir. This weir here is actually at the bottom of the catchment. So all of the area that contributes to Pocket Lake for this small little subcatchment comes through here. So it's integrating the water through this soil-filled valley, but also through these bedrock outcrops up here. And so it's forcing all of the snowmelt water through this weir. And there's a relationship between the height of the water in this weir and flow. And so we can measure continuously the flow. So we put a little water level logger in here, and it gives us a water level measurement every 5 minutes. And from that, we can get a continuous measurement of flow on the site. And then we can take water samples in the water when it backs up here. And then you combine the chemistry with the flow, and you can actually estimate the mass of arsenic that's leaving the entire catchment.
That is so nice.
Isn't it awesome? Yeah.
Training local youth in fieldwork is a priority for our team and for this research. In the future, monitoring of landscape recovery will be their responsibility.
My name is Stanley McKenzie. I'm a Yellowknife Standing First Nation. My community is right over there, directly across Giant Mine. Yeah, you can see it. And I'm currently a second year in Environmental Indigenous Science and Studies. We're there to understand the complexities of researching, conducting our own research, and learning new methods of things in the environment. It's important for many reasons, because one, it's to improve the state of the land, because right now the Giant Mine and and the areas affected around it, it's in a bad shape. I like doing this kind of work because it helps do research what's about that's potentially harming it or what is already harming it. And we can do research about how we can improve it, and maybe, or not maybe, we will fix the land. Mhm.
On the ground, the crew collects core samples to measure arsenic at varying depths. Back in Kingston, Sean uses electron microscopy to trace its mineral forms, revealing how easily each compound might leach back into our lakes.
We'll come here every day during snowmelt and measure the water chemistry. We measure things like arsenic, but also other things to understand the processes that are controlling the release of arsenic. So carbon, like dissolved organic carbon, is something important that controls how arsenic moves around the environment. So we also look at that. We also have field cameras here set up so we can actually watch the progression of melt. And we can stack those images that are taken every hour, and we can actually create a time-lapse image. So we can see when the water is flowing, when it slows down, when it speeds up. It's really handy to have a visual of that.
Preliminary data shows that most of the arsenic is concentrated in the upper few centimeters of the soil and came from the mine roaster. Runoff in the region is typically restricted to the snowmelt period and transports substantial amounts of arsenic. Both surface soils and runoff water contain arsenic concentrations several times the guidelines designed to protect human and ecological health.
What is my favorite thing? Well, it's actually doing snow sampling and water sampling and soil sampling, because we actually go in the field and actually do it, and we see it firsthand, like how bad it is. And then going back to the lab to do a little bit of a analyze. And that's my favorite part, where I'm trying to like it because I'm not really good with science, but I'm beginning to like it because the complexities behind it, and it's actually really interesting, and I enjoy that part. Once I finish my 2 years here in Yellowknife, I want to go back to Trent in Toronto so I can get my diploma. And then afterwards, once I do that, I want to come back and work in the north and do any kind of field work that does this kind of thing.
Our work at Giant Mine and Pocket Lake blends history, science, and community wisdom. Our results can be used by local communities and government agencies to make decisions regarding the availability and health of this landscape for further use.